College Algebra, Chapter 3, Section 2, the graph of a function. Objective 1. Identify the graph of a function. You've probably done this before. If a function is graphed, we can use the vertical line test. We know that a parabola is a function. If you take a vertical line and draw it any place, you cross that graph at most once. If the graph would stop here and you draw a vertical line to the right of that, that's okay to miss. But if you hit it at most once anywhere you draw a vertical line. That's the vertical line test. If it hits the graph, I'll say at most once, because it can miss it. Now, what this also gives us is the domain. Because all of these x values, this one, x of 1, here's an x of 2, x of 3, x of 4, all of these x values that we get when we draw a vertical line and hit it, in this picture up to that spot right there, but not this one because it doesn't hit the graph, all those x values define the domain of the function, because that gives us the vertical line to hit the function and then go over, and this would be the y value, part of the range. So these vertical line test does a couple of things. It gives us the information that this is a function or not, just a relation. And it also gives us the domain, whether it is a function or a relation. The horizontal line test tells us what kind of function. There are two types. There is a 1-to-1 function or many to 1. That second word being a 1 is what makes it a function. So in this case, a horizontal line test hits it more than once. If it hits only once, then it is a 1-to-1 function. 1x for 1y. If it hits it more than once, then it is a many-to-1 function. So this picture up here is a many-to-1 function because it's hitting it a bunch of times, twice. So this is a function. It is a many-to-1 function. This also gives the range of a function. Every y value, if you hit the graph, every y value that is across from or gets hit is part of the domain. One's down here, you can miss it, that's fine. But that y is not part of the domain. The range. So it also gives the range of this function. So more than one thing. Vertical line test, horizontal line test. Objective 2. obtain info from the graph. Let's see. The graph y equals f of x. This is, we've got graduation medals, right? Find f of 0, f of 1, f of negative 3, if f of x equals 3x squared minus 4. So what is f of 0? That's 3 times 0 squared minus 4, negative 4. What is f of 1? This is 3 times 1 squared minus 4. 3 minus 4 is negative 1. What is f of negative 3? 3 times a negative 3 squared minus 4. Well, negative 3 squared is positive 9 times 3 is 27. Minus 4 is 23. So, you need to be able to do that. Find coordinates for points. The first set of coordinates is that 0, negative 4. Then it's 1, negative 1. And negative 3, 23. This should satisfy the vertical line test to this function. So we can find points on the graph. We can also find the intercepts. The x-intercept is when y equals 0. So let's go back to this y instead of f of x. If y equals 0, it would be 0 equals 3x squared minus 4. That means that if you add 4 to both sides, 4 equals 3x squared. If you divide both sides by 3, you get 4 thirds equals x squared. And so if x squared equals 4 thirds, then x is equal to plus or minus. Remember, when you take the square root, you've got to put a plus or minus the square root of 4, which is 2, over the square root of 3. And we could rationalize the denominator, but finding the y-intercept, the x-intercept, there can be more than one x-intercept, and this shows it here. The y-intercept, there better only be one, because that's part of your vertical line test, the y-axis. That's when x equals 0. So you've got y equals 3 times 0 squared minus 4. We already did that. Y is equal to negative 1. So the y-intercept is negative 1. There are two x-intercepts. If we want to find, we found out where f of 0 is here. Suppose 2 is equal to 3x squared minus 4. What are we looking for there? Given a y value, we can find out what the x values might be. There may be more than one. This is like putting in a 0 for the y. But now we could put in a 2 or a 3 or anything and seeing if that gives me some x values. Sometimes it won't. We've got to be a little careful. If you got division by 0, square roots and negatives, you're not going to get real numbers. So let's do some examples. Page 227. Number 10. Wow. There's a bunch of stuff to do on page 227, number 10. Use the given graph of f to answer parts A through N. Let me take a short break and draw it for us. So this is problem number 10. Gives you the graph, and it asks the questions A through N. To be able to use the graph, it's going to give you at least 4 steps, right? So what is f of 0? We just look up here. We can plug in 0. We don't know the equation, though. F of 0 is 0. F of 6 is 0. F of 2 is negative 2. F of a negative 2 is 1. F of 3, is it positive or negative? Here's 1, 2, 3. F of 3 is negative. F of negative 1, is it positive or negative? It is positive. What x's for f of x equals 0? Where does f of x, the y value, equals 0? The y value is 0. It's here on the x-axis. These are really the x-intercepts. What x's for f of x equals 0? 0, 4, and 6. I looked ahead. The x-intercepts then are also 0, 4, and 6. What x's for f of x less than 0? Well, it's between these two, from 0 to 4. So less than 0 is, we'll see if I can squeeze this in. From 0 to 4, this is interval notation. From 0 to 4, do not include 0 or 4 because that's where it's equal to 0. The domain, well, let's do that interval notation. Starts at a negative 4 inclusive and goes up to 6 inclusive. The range starts here at a negative 2 and goes up to 3 inclusive. The x-intercepts is 0, 4, and 6. The y-intercept is 0. Number of times y equals a negative 1 intercepts the graph. So this y equals negative 1, horizontal line. Number of times is 2. Number of times x equals 1 intersects the graph. X equals 1 is vertical line. Just 1. We should have been able to answer that. This is the function. F of x equals 3. What are the x's? 1, 2, 3. Well, we might have to guess at this. It's not a negative 2. It's not a negative 1. I don't know. Say negative 1.5. When x equals a negative, what is the x's when f of x is negative 2? This one's okay. It's going to be 1. I'm sorry. When f of x is negative 2, it's going to be 2 here. F of x is negative 2, it's going to be 2. Maybe I did that last one wrong. So when f of x is 3, well, there it is. It's 5. When f of x is 3, y is 5. So this, I was looking at the wrong thing. Be careful. This is the y values, right? When does y equal 3? When does y equal negative 2? Over here, this is when x is a negative 2 and stuff. And I was looking at just the opposite. So this is a good little exercise to see what information you can get from the graph. You should be able to do these. Make sure you determine, is this a function? Yes. The vertical line rule works. What kind of function? Because it hits it more than once and all it takes is one horizontal line. This is many to 1. Okay. That should be section 3.2. There's a lot of information here. You need some practice. Make sure you get through those assignments. Before we go completely, let's do one more problem. This was using a graph. Let's go to some of the problems that are word problems on page 229. One of those, the effect of elevation and your weight. This is number 34. If an object weighs m pounds at sea level, then its weight w in pounds at height h miles above sea level is given approximately by this formula. W of h, your weight for h miles above sea level, is m, let's see, that's your pounds at sea level. Big parentheses, there's 4,000 over 4,000 plus h. So if h is sea level, then I guess that would be 0, and this would be times 1. Sort of makes sense. Squared. Interesting. So that would be 1 squared times your weight at sea level. So what is m again? M is pounds at sea level. Level. Okay. The h is the height above sea level. This is in miles. Part A, which is the fun part. Amy weighs 120 pounds at sea level. M equals 120 pounds. How much will she weigh on Pikes Peak, 14,110 feet above sea level? Now, Pikes Peak, (14,110 feet) is not the miles. H has got to be in miles. So we have to take this 14,110 and divide it by the 5,280, which is feet per mile. So this is feet, and this is feet per mile. So when you invert and multiply, the feet cancel, and this is just going to be miles. So, how do you do this on your calculator? Let's get one going and see. Okay, let's turn this thing on and clear off the screen. So we need, let's figure out what this thing is. 14,110 feet divided by 5,280 feet per mile gives us 2.6723. Now, I'm going to store that. There's a button here, stow, with an arrow. We're going to store that into the to the h, which is alpha h, because that's the number of feet, the number of miles above sea level. And we can then put in our pounds, 120 pounds, the parenthesis, then you get the numerator, 4,000, divided by, now, if you've got the new operating system, it may be a little easier, but I've got to put this in parentheses, the 4,000 plus the h. And remember, the h is that 2.67. We can use the h, which is what I'm going to do, or you could use that second ands which also holds the value we just calculated, the 2.67. But that's the denominator that I've got to close, and then I've got to close the parentheses here. So I need parentheses around that, and then square this thing and press enter. So I get 119.84. So that's your weight. Let me put this away. 119.84. Oh, this is the 2.68, whatever it was. 119.84 pounds. Now there's other ways of doing this, and I guess this is what I wanted to show you before we leave this. You can put this into your y equals stuff. So let me pull this back up, and I guess we can leave it here since that's so. Let's go to y equals, and when you get to this screen, we can put this stuff in. Now you can put in the 120 directly, or you can put in an m, but you've got to make sure that m contains that. So I'm going to put in the 120 and the parentheses, the 4,000 for the numerator, divided by, then in the denominator I've got to put that in parentheses, 4,000 plus, and this is going to be y of x. So I'm going to use x instead of h. Close that, close the big parentheses, and square it. And the nice thing about this is when you get out of this stuff, you get this messy screen. So I'm going to clear the screen off. And you can use y, just like f of x, y of x. See this vars here? Vars. Right arrow to y vars. Number 1 function. And y1 is where we put that. Of 120. I'm sorry. This is supposed to be the h, which is the 2.68, or I can put that with the h. And get rid of this other stuff, since h has the value that I need in there. You still get the same answer. If you would do alpha h and print it out, just say enter, it gives you that 2.67, etc., etc. So you don't have to retype things. You can hold things in these variables. You can use this. You can, I guess, make sure you divide the h by 5,280 and put in the 14,110. You could put that in your formula. If we take a quick look at that, we can change this formula to, let's call it W of F for feet. Now m is still the weight that at sea level, so 120 for that for Amy. The 4,000 over, remember we got to put this parentheses, 4,000 plus F divided by 5,280, close the denominator, close the big parentheses, and square it. So you could write it this way, and you could put feet in instead of this height in miles. You could do that. What are they asking? You can create the table and take a look at these and see how this varies. For Amy, let's bring back our calculator. So the table, and notice above this it says table. There's also above window says table set. you should try to do that first because you always have to set the table, right? Second window, I'm going to start it at 0 because this is going to be your X, and therefore you're going to be at 0 height and go up to whatever height you need. Now, you're going to press Enter. How you would jump, you could go by miles, you could go by tenths. They're asking here. I guess they said 0.5. So it's 0.5 for this. This delta table is how it counts by. And leave this auto, and you should be okay. Now you do the second graph to get to the tables. So at 0, it's 120 at sea level. 119.95 is in between half mile and 1 mile. It looks like Pikes Peak is a little less. Well, it's 2.64 if you'll remember. Or is it 2.68? 2.68. So if we look at 2.68 here, we should see, well, it's between 2.5 and 3, I guess. This is the 119.84, so 2.68, a little bit more. So as you go up, you lose weight. Not really. You just weigh less because the pull of gravity is less. And if you want to lose a bunch of pounds, how high do you have to go? I guess you could go up. Just to get down to 1 pound that you've lost, you need to go 17 miles above the earth, and you'll lose a pound. That's a little far to go, just because. Okay, that should be all you need for this. And now you can answer, I think, any question in those problems sets. Okay.